So Lesson Master 8.2, it asks us to find the first 4 terms in the sequence and to find the 10th term. So let's see, for number 1, our first 4 terms, the first term is 4, and then it looks like we're multiplying by 3. So when I multiply 4 times 3, I get 12, times 3 is 36, and then 36 times 3, I got 108. So I'm starting with 4, and I'm multiplying by 3 and minus 1 times if I wanted to make an explicit formula. I'm starting with 4, multiplying by 3, and minus 1 times. And the only reason I'm writing that down is because in order to find the 10th term, I think I'd rather use this than going through. I mean, I could, if I wanted to, say times 3, that would be the 5th term, times 3, that's the 6th term, 7th term, 8th term, 9th term, 10th term. And I could do that if I wanted to, or I can just do 4 times 3 to the 9th power, and I get the same thing. 78,732. Right. For this next one, it says find the first 4 terms. So when I'm going to do that, let's see, do my work over here. R sub 1 would be 1 plus 7. R sub 2 would be 2 plus 7. R sub 3 would be 3 plus 7. R sub 4 would be 4 plus 7. So I have 8, 9, 10, and 11. Therefore, the 10th term, R sub 10, will be 10 plus 7. I didn't mean to write plus 17. I meant to write plus 7 and say equals 17. Okay, let's do number 3. Number 3, it says my first term is negative 0.34, so I'm going to write that as a decimal. I'm supposed to take the previous term and multiply it by 2 and then subtract a quarter. So 2 times negative 0.75, subtract a quarter, I'm going to do 0.25, and I get negative 1.75. Right, I've got to take 2 times the negative 1.75 and subtract a quarter, and I get negative 3.75. Take 2 times the negative 3.75 and subtract a quarter, and I get negative 7.75. And I can keep doing this until I get to my 10th term. So 2 times negative 7.75 minus 0.25, and I get negative 15.75. 2 times the negative 15.75 minus a quarter, and I get negative 31.75. Going 2 times negative 31.75 minus a quarter, I get negative 63.75. 2 times negative 63.75 minus a quarter, and I get negative 127.75. 2 times the negative 127.75 minus a quarter, it's negative 255.75. 2 times the negative 255.75 minus a quarter, and I get negative 511.75. That's my 10th term. Number 4. Anytime I have a formula just like this one I didn't really feel like I needed to put into the calculator. It was so simple. This one I might go ahead and put into y equals x times x plus 1 and just pull up the table. And my first terms are 2, 6, 12, and 20. And then go down to my 10th term, and I get 110. All right, my 5th problem here. 3 times a half to the n minus 1. So I'm going to, my first term is 3, and then times a half is 1.5. Again, I can 3 times 0.5 give me 1.5 times 0.5 gives me 0.75, and I can just start hitting enter. 0.375. Now I could keep going till I got to the 10th term. That's 4, 5, 6, 7, 8, 9, 10. Or I can use the formula 3 times a half to the 9th power, because the 10th term would be 10 minus 1, which is 9. 3 times 0.5 to the 9th. And either way, I get 0.005859375. Right, number 6. See, I can tell that this is arithmetic and it's an explicit formula, just like this was geometric and was explicit. I start with -2 and I'm subtracting 4 according to this formula for every term. So that would be then -6. Subtract 4 is -10. If I need to, I can do it here. -2 minus 4 minus 4 minus 4. And I could keep going till I got to the 10th term. That's 4, 5, 6, 7, 8, 9, 10. Or I can just find the 10th term directly, -2 minus 4 times 9, and I get -38 either way. To find these terms, I could have done j sub 1, j sub 2, j sub 3, and j sub 4, and done -2 minus 4 times 1 minus 1 is 0, which is how I got -2. -2 minus 4 times 2 minus 1 is 1. -2 minus 4 times 3 minus 1 would be 2. -2 minus 4 times 4 minus 1 would be 3. So I could have found them individually, but I noticed this as an explicit formula where you're starting at -2 and subtracting 4 every time, which is why I just kind of did that in my head, because I recognized it as an arithmetic explicit formula. Number 7 asks us to write an explicit formula for the sequence in question 1, which I had kind of already done. G sub n is the first term times the constant ratio 3 to the n minus 1. Since this is the first term, my exponent is n minus 1. Write a recursive formula for the one in question 5. Okay. So my first term is 3. And I find the nth term by taking the previous term and multiplying by a half. Or you could put 0.5 there. All right, let's look at number 9. Write explicit and recursive formulas for the geometric. They've already told me it's geometric, whose first 9 terms are as follows. So to find the constant ratio, you take term divided by previous term. So I can take any term and divide by the previous. I could take 96 and divide by 48. Or I could take 24 and divide by 12. I could take 1,138 and divide by 568. Or I could take 12 divided by 6. All of these should give me the same thing. I know that 12 divided by 6 is 2. So I know that my constant ratio is 2. Now to write my explicit formula, G sub n equals the first term is 12, the constant ratio is 2, and that's to the n minus 1. Because this is the first term, this is to the n minus 1. That's the explicit formula. The recursive formula, the first term is 6. G sub n is found by taking the previous term and multiplying by the constant ratio, which is 2. So this is recursive, this is explicit. Questions 10 through 15 ask us to look at the sequences in 1 through 6 and define them as either arithmetic, geometric, or neither. All right, so let's go to question 1. Question 1, I'm multiplying to get the next term, so it's geometric. Question 2, looks like I keep adding 1 to get to the next term, so I'm arithmetic. Question 3, I multiply and I add, therefore I'm neither. Question 4, also this is going to be n squared plus n. That's not geometric or arithmetic. Remember, in order to be geometric or arithmetic, you have to have a constant ratio or a constant difference. Here I have a difference, I'm going to go back to number 3, sorry. I have a difference of 1. Here I have a difference of 2. Here I have a difference of 4. If I do the ratios and I divide, I get a different ratio every time. Here I have a difference of 4, then 6, then 8. If I divide, I get 6 divided by 2 is 3. 12 divided by 6 is 2. 20 divided by 12 is, what, 1 and 1.8. So you get all different answers. Actually, not 1.8, it would be 1.4, I think. But you have to realize that there's not a constant difference or a constant ratio, so 4 is also neither. Number 5, I can tell is geometric by the formula. And number 6, by this formula, I can tell that it's arithmetic, because this looks like my arithmetic explicit formula. So geometric for 5, arithmetic for 6. Geometric and arithmetic. I think I'll use the next video to go over 16 and 17.